Hello and good day. I should go to the page. Hello and good day. We're Algebra starting Unit 2 right off the bat with a power objective PO9, which is writing and solving equations in real context. And this does dip into pre-algebra. If you notice up here, this section are prior objectives you could use to kind of reinforce the current one. The P in front of each of them stands for pre-algebra. So this is kind of a summary of those three objectives from pre-algebra, which you technically didn't do, but you have shown understanding in equation solving, so I think we'll be okay. Someone just kind of walked me through solving a pretty standard two-step equation. If you haven't heard it referred to as a two-step equation before, you'll see why we call it that. But tell me how you would solve for n here. What value for n makes that equation true? And of course, we don't just want to go down the road of, well, maybe n is 1 and plugging it in, and no, that doesn't work. Maybe n is 5 and plugging it in, and that doesn't work. So we don't want to guess and check here. What's the process? Peter, what do you think?
Try to get n by itself.
Try to get n by itself. And how are we going to do that? Sorry, Peter.
By doing the opposite of the operation.
Right. So you may have heard this phrase before, opposite operations. And we actually go back to PERMDAS here because as we identify the operations in the given equation, to undo those operations, to isolate the variable, we'll be doing the opposite of what we have. So negative 8n plus 11 equals negative 21. What operations are in that equation as it is written? What operations does that equation have, Will? We're multiplying. We're multiplying negative 8 times n, and we're also adding. We're adding 11 to that product. Okay? Which one do we start with? The multiplication or the addition? Adam? You'd think so, right? Because PERMDAS, we just got done learning about that. Multiplication comes before addition. But if we're undoing the equation, we're actually going to start at the right of PERMDAS and work our way backwards. So we're going to start with the addition. Because we would do that last if we were doing the equation. We're going to do it first to undo the equation. Right? It's kind of like those of you that, who's changed a tire before? Okay? You do all the things to take the tire off, and then you just reverse the order to put the tire back on again, right? So that's what we're doing here. Michael?
So is there still the groups like multiplication and division and addition and subtraction?
Yep, we still got the groups here. Any addition or subtraction is going to be done first. And notice that, that identifies what the opposite is. What's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing, right? So our first step is going to be subtracting 11. We're going to undo that. And why this works is because if you have 11 and you subtract 11, what does that get you? 0. These end up canceling out, right? 11 minus 11 is 0, and so all we have left on the left side of the equation is that negative 8n. But of course, whatever we do to one side of the equation, we also must do the other side. Right? That golden rule of math. Because right now, this equal sign says that this equation is balanced. Okay? Think of like your balance scale in science class. It's perfectly balanced. Both sides are equal. If we take 11 away from one side and not the other, what's going to happen to our balance scale? Boom. Right? Not going to be balanced anymore. So if we subtract 11 from the left side, we also must subtract 11 from the right side. And now we're launched back to PO3, negative 21 minus 11. Negative 21 minus 11 is what? Caleb? Negative 32. Okay. Now what? What's our second step of our two-step equation, right? This is a two-step equation because there were two things that needed to be undone. The addition, which we did, and now the multiplication. Blake? We're dividing both sides by negative 8. Now, negative 8 divided by negative 8 doesn't give us 0, though. What is negative 8 divided by negative 8? Violet? 1. 1 n. Isn't that what we want? N by itself? We want to know the value of 1 n. Negative 8 n's, whatever n is, negative 8 of them make negative 32, but we want to know what 1 n is. So dividing by negative 8, undoing that operation, leaves us with 1 n, and then on the right side, negative 32 divided by negative 8 is 4. So 1 n, or just n if you don't want to write the 1, but n equals 4. How could you check your answer here to see if you're right? Math is beautiful in that you can essentially cheat, and I encourage it, right? It's not cheating, but you can during a history test you can't write an answer down and then take out your book and open it and check it, right? That would be cheating. But in this case, Drew, sure, yeah, go back to our original equation and plug in our value for n, 4. And see if we get negative 21. Negative 8 times 4 is negative 32. Negative 32 plus 11 is negative 21. It checks out. Is this exciting? No? Okay. I think it is. All right. So go ahead and take a look at the next example there. Very similar to what we just did here, right? What are the operations in the equation? We again have multiplication and addition. Think about where you start. Okay? We're undoing this, so we want to work through it backwards. I'll give you about 30 seconds to kind of play with it a little bit, and then we'll talk about it. Dead air during a YouTube video is never really a good thing. I need like some interlude music or some intermission music or something, just to appease the viewers. What do we do first here? What's our first step? James? Subtract 17. We're going to undo that addition by subtracting 17. And on the left side, if we have 17, we take away 17. That cancels out, right? We are left with just 3n. And on the right side, 77 minus 17 gives us 60. Okay? Second step. Yeah, Morgan. Divide by 3, right? What's the opposite of multiplying by 3? Dividing by 3. We know that whatever n is, 3 of them make 60. But we want to know what 1 n is. So we're going to divide those 3 n's by 3. And 3 divided by 3 cancels out because that equals just 1 n, or just n by itself. And 60 divided by 3 is 20. Okay? Check that answer. Plug it back in. 3 times n, or 3 times 20, plus 17, that equals 77. Hooray. Okay. The most common mistake that folks make with this is they'll start way back at the beginning here. Instead of subtracting 17, they'll add 17. Okay, so if you did that, if you were to add 17 instead of subtract, you'd get 3n equals 94. Dividing that by 3 gets you 31 and a third. Not that your answer can't ever be a decimal or a fraction, because it will. It won't always work out to be nice and pretty like 20. Okay, but if you got 31 and a third as an answer, if you plug that back in here, you'd see, oh, that doesn't work. Okay, so checking yourself, really, it doesn't take long, and it can mean the difference between a right answer and a wrong answer, or passing PO9 and not passing PO9, right? The next one here, n divided by 5 minus 6.5 equals negative 4.5. N divided by 5 minus 6.5 equals negative 4.5. Who knows what we do first here? William? Add 6.5. Yeah. Identify that addition or subtraction. And we're going to undo it. Because if you have negative 6.5, because this subtraction sign, remember, it makes that 6.5 negative. So if you have negative 6.5 and you add 6.5, what do you get? Negative 6.5 plus 6.5? 0. They cancel out. Okay? So now we've got n divided by 5. What's negative 4.5 plus 6.5? Negative 4.5 plus 6.5 will?
2.
Positive 2. Okay? So we have n divided by 5 equals 2, or some number divided by 5 gives us 2. What is the value of n? Some number divided by 5 is 2. What's the value of n? Peter?
10.
It is 10. Mathematically, using opposite operations, how do we get there? What would we do to n divided by 5 to get a value of n equals 10? Drew?
Put 10 in for n and make it a proper fraction.
Okay, if we knew 10 was n and n was 10 and we were checking it, that's we would plug that in to get 10 fifths, or 10 divided by 5 is 2. But following this two-step opposite operation method here, what would we do to n divided by 5 to undo that dividing by 5, Peter? We're going to multiply by 5. Okay? Whatever n is, if we're dividing it by 5, to undo that, we are multiplying by 5. Those 5s cancel out, and 2 times 5 on the right side is 10. And then, as Drew said, plug that back in. 10 divided by 5 is 2. 2 minus 6.5 is negative 4.5. Okay. Quick show of hands. Review for some, for most, half, most. Okay, good. The last one here, I'm going to pause the video, give you a chance to do it yourself and not have the dreaded dead air. So we'll be back in a jiff and carry on. Okay, who'd like to raise your hand and tell us our first step here? N divided by negative 6 minus 4 is negative 15. Blake? Add 4. Start with that addition or subtraction. This was on your pretest. What is that number without a variable? Here it's negative 4. Here it's negative 6.5. Here it's 17. The first one it's 11. What is that called? We mentioned it briefly. Yeah, Sydney? It's called the constant. Okay, so you always want to start with that constant. Okay, and the reason why it's called the constant is its value doesn't change depending on what n is, right? If you plug in different values for n divided by negative 6 will equal different things depending on what n is, right? But that doesn't affect the minus 4 here. Okay, so that part of the equation stays constant regardless of what value you plug in for n. But that's where you start. The opposite of a negative 4 is a positive 4, adding 4. So we're going to do that. Negative 4 plus 4 is 0. That cancels out. N divided by negative 6. Negative 15 plus 4, check yourself here, is a negative 11. Okay? Not negative 19, negative 11. Back to PO3 a little bit. And then what are we going to do to get n by itself? Second step. Anybody that has not answered a question yet that wants to become YouTube famous? Thomas.
-6 times -11.
Yes, we're going to multiply both sides by negative 6, which on the left side cancels that out because it undoes dividing by negative 6. And on the right side, negative 11 times negative 6, we get a positive 66 as an answer. Okay, plug that back in, check it out. 66 divided by negative 6 minus 4 equals negative 15. Okay. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms on that? Okay. Then we move on to word problems. Okay. Looking at a situation, identifying what's important, what do I need, what's my equation here, what operations. So it says you sign up to help a charity with preserving the rainforest. That's all kind of you. They ask for $20 up front, and then you will give $2 per month after that. Write the equation. How much money will you have given after 6 months, after 8 months, after 2 years? Okay. What's our equation going to look like here? Who's got an idea? An equation that will give us the total amount of money given based on different lengths of time. Sepa? So we don't need an equals here yet because this expression will give us that value. But yeah, 2m plus 20. Okay, this plus 20, why is that our constant? Why is the variable separate from that plus 20 there? William?
Because it's up front.
Because it's up front, right? That part doesn't change whether you are a member for 6 months, 8 months, or 2 years. You still gave that $20 up front regardless of how long you end up contributing to the charity. That 2, and who knows what that 2 is called? We mentioned it yesterday. Blake? Very good. The coefficient tells us how many of the variable we have. Okay? Or the value that each m represents, right? 1 month is another $2 to the charity. 6 months, do this one first, 6 months is another $12 to the charity, right? So that expression is correct. We're plugging in 6 months total. We would have spent 32 or given $32. Okay. After 8 months, what part of the expression changes? Will? The variable, right? Now instead of 6, now it's 8. 2 times 8, 16, plus 20. We've given a total of $36 here. And 2 years. What am I plugging in for the variable for 2 years? Violet? Well done, 24. Why 24? Will? Right. What unit is our variable in? It's $2 per month. So we have to convert this to months, 24, and that's what gets plugged in. So 48 plus 20, $68 total. The next one, Mr. Schultz has 3,039,001 hairs on his head, and each day he loses 60 of them. That's probably true. Write the equation. How many hairs will he have left after 120 days, 1,580 days, or 50,650 days? For starters, what's the equation here? What's going on? What's happening? Adam? 3,039,001 minus 60, and then whatever variable you want to use. D for days seems to make sense. Okay? 3,039,001 is our constant, right? Because that's where we're starting. Okay? That's what I currently have. And then minus 60 hairs per day. For every day that passes, we're subtracting 60 from that total, right? Which is why the order of operations makes sense here. You know, I wouldn't subtract 60 from my total and then multiply by the number of the day. No, I want to figure out how many days have passed. Each day I've lost 60. I'm going to multiply first. How much have I lost total? And then subtract that from the original amount, right? So your three calculations, you've got 3,039,001 minus 60 times 120. How many hairs will I have left after 120 days? Who's got that calculation for us? Caleb.
3,031,801.
Still a lot, right? I can still do a lot with that. Straighten it, maybe braid it, whatever I want to do. Okay. Next one, 3,039,001 minus 60 hairs after 1,580 days. How many hairs do I have left? I'm just replacing that variable, the number of days, with a new value that I want to test, right? My original total doesn't change, but how many hairs I've lost at this point, unfortunately, does. Caleb? 2,944,201. And lastly, 50,650 days. I've got my original 3,039,001 minus 60 times 50,650 days. How many hairs do I have then? Gino? Just one. Just one hair. I hope it's really long so I can like wrap it around and cover, you know. But yeah, after all that time, just one hair left. Okay. Whew. Luckily though, if this actually is true, if I make it to just having one hair left, 50,000 days is like 135-ish years old. So I would take that, live that long, left with one hair. Yeah. Yeah, that'd be good. So, first of all, any questions on any of this stuff? The process for solving a two-step equation, how we got the expressions that we got up here. Remember, your constant is the thing that doesn't change, right? My total number of hairs I was starting with didn't change. The $20 you gave up front didn't change, right? That was constant. And then you got your coefficient and your variable. So for homework for tomorrow, I'd like you to practice here with these 8. Okay. It does say show all of your work. We've run into the past where some folks have come in without work shown and said you did it on a separate sheet of paper. If that's the case, then attach that separate sheet of paper so I can see it. Okay, but I need to see you practicing that mathematical process and then check your answer, of course. Then at the bottom, 2 questions. You are just starting to collect baseball cards and already have 30 that you got from your parents. You go to a trading store with 3 of your friends with the agreement that however many cards the group gets, you will divide them evenly among the 4 of you. How many cards will be in your collection if the group gets 40 cards, 96, or 224 cards? So you're writing this as an expression, okay, and then plugging in those different values to get the total number of cards in your collection. You had questions like this on your pretest yesterday as well. Then, as a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. The pressure at the surface of the water is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. What will the pressure of the water be when the diver has descended 10 feet, 25 feet, 150 feet? Okay? Any questions on what you are expected to do for tomorrow? Excellent. Just a reminder that when this link is posted in Google Classroom, there's also a Google form. So if you do have something that you're wondering about, maybe not quite sure how to put it into words yet, or you're doing the homework and you realize this question is really hard, I'd like him to talk about it, or something comes up that you want me to discuss tomorrow, put it in the Google form, and I'll see it, and we'll start class with that tomorrow. Okay? That, folks, is how you math.